Hi, I am Atan Singer, and today I am presenting from our work at the Fair Transit Lab at the Technion, together with Karl Martens and Aviv Cohen-Zada. Today's work is part of a broader project in which we develop the Accessibility Sufficiency Index, or ASI, to examine various aspects of transport systems in the US. Traditional approaches to evaluating the performance of the transport system typically focus on issues like congestion and ridership. Yet these measures do not capture the main goal of the transport system, that is to allow people to access the destinations they desire to reach. Recent accessibility studies aim to address this shortcoming, but these studies do not set an explicit benchmark against which one can evaluate performance. As a result, they do not tell us whether the transport system provides sufficient service for conducting daily activities. In our project, we apply an accessibility-based performance measure and examine what transportation and land use factors explain whether the transport system provides adequate service. To this end, we adapt the Accessibility Fairness Index proposed by Martens to analyze performance of transport systems. The adapted ASI has two useful characteristics. First, it takes into account all affected individuals rather than focusing on average outcomes. Second, it evaluates outcomes against a predefined performance benchmark. In our analysis, we assume that the car provides adequate levels of accessibility. Accordingly, we define our performance benchmark as a percentage of regional average car accessibility using a range of sufficiency thresholds, ranging from 1% of average car accessibility to 50% of average car accessibility. The Accessibility Sufficiency Index is calculated based on the difference between the transit accessibility levels that individuals below the poverty line experienced in 49 of the largest metropolitan areas in the US, and the accessibility sufficiency threshold, which is a percentage of the average car accessibility in each region. A lower ASI score indicates that the transport system performs better for individuals in poverty. The analysis I present today, we model the metropolitan ASI score on factors like population size, vehicle revenue miles, congestion, and sprawl using ordinary least square regressions. We report standardized beta coefficients since the regression coefficients are less meaningful in this context, and our main goal is to identify the factors that have a stronger association with ASI. First, we plot the ASI scores of the 49 regions, or the blue dots, alongside VRM, the red bars, and sprawl index, the gray bars. This is only descriptive, but we can see that regions with lower ASI scores also tend to have a more compact urban form and higher VRM. These regions include Milwaukee, New York City, San Francisco, and Boston. On the other hand, the regions with higher ASI scores tend to be more sprawling and auto-oriented. On this slide, we show the results from 4 OLS regressions, each using an ASI score that is based on a different sufficiency threshold. We find that transit provision, VRM, has a stronger relationship with ASI when the higher sufficiency thresholds are used. This means that VRM is more important to ASI closer to the metropolitan core. On the other hand, land use patterns have a stronger relationship with ASI when the lower sufficiency thresholds are used. This means that sprawl is more important to ASI in suburban or peripheral areas. To conclude, the results show that the ASI provides meaningful insights for evaluating the performance of transport systems. Specifically, it shows that transportation and land use factors have a complementary relationship with transit system performance. This means that efforts to improve transport system performance have to combine transport and land use interventions. First, public transport and land use interventions tend to work at different spatial scales. Second, land use planning should also be informed by person-based transit performance. Thank you very much for listening.